Hello, everyone. It's great to be here today. I really love talking about how you can take your relational database and move it into a graph database because graph databases are so much more powerful and performant for many common use cases. So I added this subtitle here, Harnessing the Power of the Graph. I hope you enjoy this presentation. If you have any questions after the webinar, you can feel free to reach out to us on Stack Overflow or Google Group, or there's actually my Twitter handle here as well. You can reach out to me there. So our agenda. First of all, we're going to talk about the origins of Neo4j as a company and the Neo4j graph database. And then we're going to talk about the benefits of graph databases and where they're most powerful, and then go into designing your graph database model. And then I'm going to show you some amazing queries and how easy it is to perform some types of queries in a graph database versus what you may recall from doing in a relational database. Talk very briefly about how you can fit Neo4j into your enterprise architecture, and then of course, as Greta mentioned, we'll have a Q&A period where you can all ask your questions and you can start typing them now into GoToMeeting. So Neo4j as a company, the actual company is called Neo Technology, and we've created Neo4j. It's been around for a while now. We have over 80 employees all around the world and a very large amount of funding to build this product, which is Neo4j, which is the world's leading graph database. We've built a huge customer base around this, over 150 enterprise subscription customers, including many of the world's biggest companies. Neo4j has been adopted by verticals all across the board. Every different type of industry finds that the power of graph databases can really help them make their business faster and more intelligent. And customers are using it for all sorts of different types of use cases. So from social to recommendations to master data management to identity access, a lot of different types of use cases find the power of graph databases to be quite important and easier than relational databases to accomplish their business goals. Neo4j is really the world's leader in the graph database revolution. We started as an open source project many years ago, and in the last few years went as an enterprise product, and obviously have proven it to many customers, how powerful graph databases can be. And so you have a couple quotes here from leading analysts like Gartner and Forrester about how graph analysis is the single most effective competitive differentiator for organizations pursuing data-driven operations and decisions after the design of data capture. We're going to show you how you can do the modeling of your data as a graph database and how it makes it a lot easier to query. So nowadays, data is changing. Databases have been around for a long time, but data is increasing in its size and is getting a lot more connected. We call graph databases as the way to perform amazingly fast queries on connected data. In fact, nowadays, most data is connected. If you think about your customers, your products, your processes, all of this data is connected to each other, and you want a database that makes it really easy to query that connected data, because that allows you to unlock the value in all the different use cases that we talked about earlier. Early adopters of graph database technology include folks like LinkedIn, Google, and Facebook, who recognize the power of this technology for their business problems. Ironically, based off of the name, relational databases can't really handle relationships that well. So it's very difficult to model and store complex relationships in a relational database. And as you query it, you end up getting a lot of performance degradation when you have a lot of inner queries, a lot of self-joins and things like that. And this makes it really difficult from a performance perspective, but also makes it difficult for your DBAs and developers to write the queries. So it just adds to the complexity of design of your data model, adds to the complexity of development and adds to the time and cost of development, but also adds to the system infrastructure needs that you need in order to run a relational database on highly connected data. So if you want to unlock the value, let's talk about how you can model your data as a graph with your data nodes and the relationships between your data nodes, and then use that relationship information in real time to transform your business. And also, one important factor with regards to Neo4j is that you can add different relationships and properties on the fly as your business changes. So you don't need to re-architect your SQL table schemas and that sort of thing. You can just add properties on the fly with Neo4j. So modeling as a graph. The whiteboard model is something that most people start off with as they're designing their databases. They talk about, what are the different objects, and then what are those objects doing, sort of nouns and verbs. In the case of a graph database, though, the whiteboard model is really the physical model. So you whiteboard out something like this, and then you create the physical model that is stored on disk in Neo4j, and the physical model looks identical to the whiteboard model. This makes it a lot easier to align the thoughts and the processes of the business folks within your organization with those folks that are actually architecting and developing the applications. So I want to talk a little bit about the different components of the property graph, as we call it, which represents the graph that you have stored within Neo4j. You have nodes. These are the objects, the nouns in the graph. Each of these nodes can have properties, and they can be labeled as a particular type. And then you have relationships. Relationships are a way to define the relationship, obviously, between the nodes, each of the nodes within your graph, and then they can have properties on those relationships. So here are the properties on our nodes, and then here are our relationships and the type of relationship. So in this case, this person loves this other person, and luckily for Dan and Ann, that love relationship is mutual. They both love each other. It would be sad if it was only one direction. And Dan lives with Ann. And Dan and Ann both drive the same car. And you can see here on the Dan node, the relationship drives also has a since January 10, 2011 date on it. That's a property that is on the relationship. So this allows you really to model the data as you think about it from a business processy. Although, for most of us, unless we're building dating apps, this isn't a real business style graph. So we're going to get into one of those here shortly. If you think about how you would do something in a relational database in a similar way, to say someone is a friend of someone else or someone loves someone else, you would typically have multiple tables in your database, and then you would have a join table that specifies how you map the people together in those relationships. And that, if you think about that from a visual standpoint, that looks a lot different than how you think about it when you're actually modeling your underlying database in a relational database. And with graph databases, we aim to kind of make those two much more similar, make your whiteboard model the same as your underlying physical model. So let's model some more business data instead of talking about Dan loving Ann, which is probably a little bit more fun depending on who you are. But let's talk about actually modeling customers, suppliers, and products and orders. These different types of data are popular in many types of businesses, pretty much every type of business. And this is an example use case for master data management. So here's how we would model it on a whiteboard, or how we would model it in a graph database. We have an employee who sold an order that contains a product. That product is part of a particular category, and that product is supplied by a particular supplier. It's really easy to model this out visually in a graph. Except if you were to model this out in a relational database, if you look at the ER diagram, this adds a few extra tables here, but not many. And you can see that it looks just so much more complex. It's something that maybe the DBAs can understand, but it's very difficult for the business folks that are designing these processes to really understand on a day-to-day basis. And like I said, we aim to make these, align these two better, align the model that the business folks think of along with the model that the developers are thinking of, just to make things so much faster in designing and developing your applications and your data. So we're going to talk about the requisite Northwind example. For those of you familiar with Northwind, this is a data set that's been out for many years now, probably decades, that really models these types of data that we just talked about. And the funny thing is it is supposed to be the canonical example of what a relational database looks like. But in reality, the Northwind example proves to us that it's difficult to model a lot of this type of data in a relational database and so much easier to model it in a graph database. So we're going to talk about how you take Northwind from a relational database model into a graph database model. So in this case here, we're going to be taking a subset of the Northwind data, and here we're saying the employee sold, the employee is a node, sold as a relationship, and order, which is another different type of node. So let's take a look at that. Let's take a look at the ER diagram and look at what types of data we had in our relational database. In this case, there's a lot of different foreign keys. We're going to remove those foreign keys because they're not really needed in a relational database model, and because they really just add complexity. So we're locating them, we're crossing lines through them, and then the foreign keys become the relationships because that's really how we think about it. The foreign key, in this case here, the product is in a category. Instead of the product having a category ID in it, we simply have the relationship directing from the product to the category that it is in. Similarly with a supplier, we have the supplier supplying a product instead of including the supplier ID as a foreign key element inside the product table. And then our join tables. There's some tables here that are simply exist to join other tables together. And we really want to remove that complexity, and we want to just make it much easier to look at our data. So our join table, like order details, actually becomes a relationship. And so the order details becomes the details property, and we can say, sorry, the details relationship, and we can say that a particular order includes, and that's the relationship name, a list of products. And those products are different nodes that the orders will point to, and they have different properties on that relationship, such as the unit price, the quantity, and the discount. So here's the subset of data that we're going to be working with today. And I promise we're going to get a little bit back out of the technical detail here shortly and show you some actual queries and the power of graph queries on this type of data. So here's how we're modeling it: an employee sold an order. An order contained a product. Notice I didn't really name that relationship that well, but if I were to rename it, it would say the order contained a product. The product is part of a particular category, and the supplier supplied a product. So now we've modeled our graph database. We want to show you how easy it is to query this type of data. And the first type of query that I'm going to show you is about reporting relationships. So part of that data set is employees' relationships with their managers. So in this case, Stephen reports to Andrew. And you can see a very, very, very simple query at the bottom there to say, find the nodes such that you're looking at where Stephen reports to Andrew. But that's information that we already know. So let's get into a little bit more complex queries. But I just wanted to point that query out to you so you can see where the labels are in the queries and where the properties are. And then obviously Stephen and Andrew, as we introduced earlier, are nodes. So here's the way that we would run this query inside our graph database. A very basic query: who do people report to? So we're matching all the employees and their subordinates that report to them, and then returning all of those nodes. And the result becomes something like this. This is the Neo4j query browser. It's one way that you can access Neo4j data, and it provides a highly visual interface that allows you to see your actual graphs. And I'm going to actually try switching over to my web browser here if I can. And 1 second. Okay, so you can see my web browser here, and we can see this query actually being performed in the Neo4j query browser. And in the Neo4j query browser, we're literally just saying, who do people report to? But it's fantastic because if you just did this as a tabular list, it would be very difficult to see some of these more complex relationships, such as Michael reports to Stephen, but Michael is also an indirect report to Andrew because Stephen reports to Andrew. That would be much more difficult to see in a relational database with such a simple query. But we could return it as a table here. So I did have a different version here where we're returning those results as a table where the manager is listed along with each of their employees. Now let's do something that's much more complex. Finding all the direct reports and how many people they manage up to 3 levels down. In SQL, this query would be rather huge. This would be a query that does a lot of self-joins onto the tables representing the employees. And this is actually something that came from a customer of ours that they were running this SQL query. In Cypher, the query language that Neo4j uses, the query would look something like this. Quite simply, you're basically matching the subordinates and who they report to up to 3 levels down, and then you're returning the data of the subordinates and a count of total reports. And it's really much easier to perform this type of query, and it demonstrates really the power of a graph database. So here's a quote from one of our customers on eBay, and they literally found Neo4j to be thousands of times faster than their previous solution, with queries that require 10 to 100 times less code. This is really, really important proof point on the power of graph databases, because not only is it easy to develop, saving you a lot of development time, but then the solution that you build is actually a lot more performant because of the native graph database storage model that is used by Neo4j. So let's show you another example. For instance, here, who is in Robert's direct upwards reporting chain? So we want to see who all is above Robert in the reporting chain. And again, that's a very simple query here. We can match an employee reporting to, or sorry, a subordinate reporting to an employee and find the entire path, which is what that P equals is, where the first name of the subordinate is Robert, and return that path. And that looks something like this. So we can see here that Robert reports to Stephen, who reports to Andrew. And Andrew here, you can see, is sort of at the top of the reporting chain. So Andrew represents the big boss. And I'm going to jump back into my web browser and show you how you can run this query to see who the big boss in the organization is. Okay, so you can see I'm back in my web browser here, and I have the query that I had over in my presentation, and we're saying matching the path for the employee where the employee doesn't report to anyone, in other words, the big boss. And if I run that query, I get a very simple answer here that Andrew is the big boss. I've tried to do these types of queries in past roles to find everyone that reports in an organization with direct and indirect reports. And it literally took me a few hours of querying in a relational database model to develop this type of knowledge when you have a large reporting chain. In a graph database, it's quite simple, and the Cypher query language, while being very similar to something like the SQL query language that many of you are familiar with, is and easy to learn like SQL. It actually really takes advantage of the graph database model, and we try to not only represent the whiteboard model in a similar way as a graph, but we also try to represent the query language to how you think about the data, to how you think about how the data is structured. So you can actually even see these arrows that exist within the query. And that's really how we think that developers, as well as business folks, are thinking about the data and the relationships between the data. And then I'm going to show you one other query here. And this is product cross-selling. This is a rather complex query, but we want to see, or a rather complex result and with a simple query, but we want to see all the products that are sold along with the product called chocolat, and who sold them. And so basically we're looking for all the other products that are in the same basket, the same order as chocolat, and the employees that sold those orders, along with how many times those products were included along with chocolat. And so let me just jump back over to my browser. I'm going to show this to you live. I have these screenshots in the slides, but I think it's much better for you guys to see this live running in Neo4j. All right, so you can see here my query is up top here. Match where the product name is chocolat, and it was sold by an employee, and then we're returning the information here. I'm just going to hit the simple play button in the Neo4j query browser, and we're going to see this list of other products that are sold along with chocolat and how many times they were included in the same order as chocolat. So in this case, I'm not even going to try to pronounce Nancy's product here, but Nancy sold this product 37 times along with chocolat. And here's one I can pronounce. Margaret sold Boston crab meat 31 times along with chocolat, and pâté chinois 28 times along with chocolat. All right, now to jump back to the presentation, you can actually see, or you just did see how simple it is to perform that type of query. For those of you who are experts in doing relational database queries in SQL, just think about how difficult that query would be to perform in a relational database versus the few lines of Cypher code that we have here. But not only is it easier to develop and easier to query, but Neo4j provides a super high performance system for running your queries on your data. So we provide this performance in the Enterprise edition of Neo4j by allowing you to have a cluster of Neo4j servers. And this cluster provides master-slave replication with automatic failover in case of issues with your systems. And then each instance has its local cache, as well as there's cache sharding that can be spread across all the different nodes for very large graphs. So when you run a query, you can run it on any node determined by your load balancer and get the results very quickly. And when then you're writing your data, you can write it to any node, but in the end it will go back to this master node for replication over to each of your other nodes. This allows you to do super high performance, large number of queries, and very easily scale your querying of your Neo4j data. But how do you get your data into Neo4j? It's actually quite simple to load data into Neo4j. All of you are probably familiar with CSV files. Those have been around almost as long as relational databases. And the CSV files make a really easy format to load data into Neo4j. So you can use a Cypher command. So in a query language format, like we just saw with actually performing queries, you can also load your data in from either local data or remote data over HTTP or things like that, directly within that query language. And this is really good if you want to load small amounts of data up to 10 million nodes and relationships. But if you want to load billions and billions of rows of data, we actually have a command line bulk loader tool that we use to load data in, and this loads data in up to 1 million records per second. And so you can see an example here with DBpedia loading in 4.58 million things and all of their relationships in 100 seconds. So it's super quick to load your data into Neo4j. And as you saw with the query browser, it's really easy to play around with the query browser and understand your data after you load it in. So we have customers loading their data in a couple different ways. One is they're migrating all of their data from a relational database to a graph database. Sometimes this makes sense. Like I said, we have highly connected data nowadays. Much of our data has relationships at the forefront. And so if that's the case for your data, load it all into the graph database and proceed forward from there. In some cases, people like to migrate some of their graph data over to a graph database while keeping their relational database around for their tabular data. So this is what we call sort of polyglot persistence, allowing your data to sit in both a graph database as well as a relational database, depending on the type of data that you have. Take advantage of the best database for the type of data. And then some people actually duplicate all of their data into a graph database and a relational database, depending on what type of data they're storing and who's querying it and that sort of thing. So there's all sorts of different ways to maintain or load and maintain your data in a graph database in an enterprise environment. So we just talked a little bit about polyglot persistence, but let's talk about how your applications fit with Neo4j in your enterprise environment. So your application connects to a graph database cluster, you have an end user accessing your application, and then you might have other databases, whether they be other relational databases or other NoSQL databases or Hadoop file systems that store your data. And then you can have a data scientist who sits on top of all of that and does ad hoc analysis on the graph or builds applications on top of a bulk analytic infrastructure that connects to your graph database to discover all of those relationships. Let me actually, before I talk about how users love Neo4j, I just want to talk about an important point here, is that to date, or up to this point in the presentation, I've showed you the Neo4j query browser, which makes it really easy to select your data that you want to query, run the Cypher queries, and there's all sorts of things that you can do within the query browser. But we're not just a BI tool. Neo4j has the query browser to make it really easy to develop and run your queries in sort of an interactive way. But the real idea behind Neo4j is that you're building applications on top of it. Here's a very simple Python application that I built in probably 15 or 20 minutes, outlining the employee relationships that we saw here. So both the direct as well as the indirect reports. I built this application in Python. You can access your data in Neo4j using any of our drivers for a variety of different languages. So whether you're working in Java or Python or Ruby or JavaScript or C#, you can access Neo4j using any of those languages to build your applications. And there are drivers out there that make it a lot easier. If you choose to build your own driver, you can do that too. We hope you contribute back to the open source community because we at Neo love open source. But you can build your own driver and access the HTTP protocol directly in order to run your queries as well. Neo4j also supports an embedded mode so that you can actually have Neo4j database directly within a Java application as well. but many customers prefer to use the Cypher query language and access it over HTTP. And we really have a lot of users who love Neo4j. I just wanted to include some of these quotes. I actually recently joined Neo a few months ago, and I came to Neo because I love the company, the leadership of the company. I love graph databases and where they're headed in the future, but I also love the amazing community around Neo4j. Here's quotes from some amazing people. So John Resig, for those of you who are developers in the audience, you may recognize his name as the creator of jQuery. He wrote, really digging Neo4j. What used to be a bunch of complicated analysis scripts are now a handful of simple Cypher queries. And other people have very similar comments. So we have this huge community around Neo4j that really loves it as a product, and it makes their lives a lot easier to both develop and run their infrastructure on a day-to-day basis. So how you can get started. Given my background, I worked a lot with platform as a service environments and did not work as much with sort of downloaded software where you run on your own enterprise architecture. And so I had this misconception when I first came to Neo that it would take a while to get started and get running with Neo4j. That's simply not true. I proved that to myself by developing a video here that in 1 minute I was able to download and install Neo4j and get it up and running and be in the query browser. And it was actually 1 minute and 3 seconds, so hopefully forgive me for that last 3 seconds. But then, not only was I able to then get started that quickly, but then in another minute and a half, I was able to run a bunch of queries and discover interesting relationships in my data. So you can find this video for our upcoming release. I'm going to be making a new version of this video for the 2.2 release that we're coming out with shortly. That will probably not include my dog in that version of the video. But if you want to see the one with my dog in it, you can feel free to check out, search the web for 1 minute Neo4j getting started video, and you'll find this. But if you're trying to build a whole project around Neo4j, you're trying to move a lot of your enterprise data. I understand that you might not do that in a minute or 2 minutes. It might take a little bit of time, but we have the professional services team around helping you out with building your Neo4j graph database. And the professional services plan can do things like help you understand Neo4j, help you decide on your architecture, help you model your data. And then you guys can go off and build your application and test your application. So you get all this done in as little as 8 weeks from what we've seen with real customers. And then there's lots of other ways to get support from the community with Neo4j. We of course offer expert enterprise support plans, but we also have this very large community around the world that's available for you to learn from. You can ask questions on Stack Overflow, and many of those questions are answered by other folks in the community that are just as excited about graphs as we hope you'll be. And we also do answer many of those questions as well. And there's also meetup groups all around the world to learn about Neo4j. There's this huge ecosystem. We have over 1 million downloads of Neo4j, 18,000 members of our meetups, and 100+ technology and service partners. This means that if you're trying to find people who are highly educated in graph databases, you can find them. But I do want to reinforce the idea that Neo4j is really easy for folks who are familiar with relational databases to understand and start learning. Like I said, that Cypher is a query language that is modeled based off of what you need for querying graph data or highly connected data. But it is still very similar to SQL in terms of the overall syntax. So we think it's really easy for people who have SQL knowledge to start learning Neo4j and the Cypher query language. And then you can be part of that ecosystem. So I encourage everyone to get started now. You want to take your relationships and your connected data seriously, and Neo4j makes it seriously easy to model your data as a graph. Gives you serious performance, and it fits within your enterprise architecture. And perhaps most importantly for those on the call today, it's really easy to get started and fast to reap the benefits of graph databases. So I encourage you all to, if you haven't already, to download Neo4j and get started in 1 minute. If it takes you 1 minute and 3 seconds, my apologies, but reach out to me if you're having any issues, either on Stack Overflow, or you can reach out to me on Twitter directly. But it is really fast to get up and running with Neo4j, and there's even some guided tutorials here. Let me just show these to you quickly here. There's even some guided tutorials when you first load Neo4j. You can see this play welcome option here. And if you do that, it actually guides you through graph databases and some models, and you can just really easily get up and started over your lunch break. So encourage you all to do that. And like I said, reach out if you have any questions after today, but for now, we'll take some questions in our Q&A.